All right, so today, here's what we're doing today, guys. We are going to be talking today about... Shush. Let's get me in the recording now. Great. All right. This is under 3. What are we in? 3.2? Yeah.
Yeah.
3.2.2, and this is polynomials. Okay? So this is underneath... Yes. This is underneath 3.2, which is factoring review. But now we're going to talk about the polynomials and specifically the polynomials. Now, we've used the word polynomial a bunch this past month, but I really haven't told you guys what it is. So a polynomial, so let's get some definitions down, okay? All right, so what is a polynomial? Okay, a polynomial is a monomial or a sum of monomials. Okay, this is where things get a little weird because technically you could say, oh, does that mean that 4x squared is a polynomial? Yes. Is it also monomial? Also yes. So they're basically interchangeable because you can still have that because you can just add plus 0 in the end and voila, it's a polynomial. Or plus 1, it's a polynomial. So when they're by themselves, they are basically two-faced. When they're together, they are always polynomials. Okay? So now term-wise, okay, the monomials are what make up the polynomial. Okay? Now, when we refer to like terms, okay, which is something I also mentioned briefly throughout this week in the other videos, is are terms that contain the same variables and, I might actually want to underline that, variables and exponents on those variables. Okay? Now, this is where we talk about things like monomial, binomial, trinomial, and so on, okay? Now, as we get further into the unit, when you hear the words quadratic and basically any of the nomials conceptually are related, but they're not the same thing. And what I mean by that is that if you have a binomial, which is two unlike terms, and a quadratic, well, quadratics only have like terms in them. So that's why they're not classified as a binomial. But they are classified as a polynomial. So quadratics are that weird special case, essentially, to this. And then inside of quadratics, you have other special cases. So it's kind of like the whole Russian nesting doll effect all over again. Only this time we're talking from terminology. Now, here's the good news. I'm not going to throw any curveballs in you involving the terminology, okay? We're only worried about quadratics, but I'm just showing you the terms because as you get higher in other mathematics, these terms become super important for understanding what's going on because people are going to talk in this language. So I'm teaching you guys basically now the language behind all this, okay? Now, on that note, let's talk about both of those, okay? So, binomial okay, is a polynomial with two unlike terms. All right. So for example, that would look like the following. A squared plus 2b, where our two unlike terms are a and b, respectively. Okay? Oops. There's a parentheses over there. All right. Another example would be 5x cubed plus 9y squared. Okay? Again, where our two unlikes are x and y. Okay? Therefore, you could imagine a trinomial. Whoops. Red, please. Okay. Is a polynomial with three unlike terms. Right? So, for example, that would be something like a squared plus 3b plus 4c squared. Okay? Or another example, because you don't even need to actually have three variables in there, or three letters, basically. You could also have 2a squared plus 5a plus 7. Now, notice something here. This guy right here is eerily similar to what I was showing you guys beginning of class, which of course was our x squared plus 2x minus 5, okay? Quadratics basically fall under trinomials, okay? This is where things get weird, because your brain mentally wants to say, wait, when they binomials, because there's only two variables there, we're not talking about the variables, we're talking about the number of present monomials. 1, 2, 3. Yes, 7 can be a nomial. It just doesn't have a variable on it. Big deal. Okay?
When are you going to speak English?
I am speaking English.
Are you sure?
Yes. All right. Now, as we discussed earlier this week with adding and subtracting these guys, right? So, when we add these, oops, wrong side. Do appreciate everyone's patience. I forgot my notebook today.
What math do we take next year?
3. Now.
You teach math 4, right?
No. All right. So we combine like terms only the coefficients change. Okay. And try to write your answer in descending large to small order of the exponents. Okay. So I'll just gonna do one example for add and subtract because we've been practicing these all week. I'm just giving you guys some formal terminology to go with. Okay. Huh?
This is the start of the week. You said we've been practicing these all week.
Last week, sorry. We practiced these all last week. So I'm just giving you guys some now terminology to go with them, okay? So an example would be, let's say I had 3x squared 2x plus 3, close, plus 4x squared minus 6x minus 7, right? So all we're doing is we're just adding this to here. What's up?
What does it say after answer and
Descending. Descending, sorry. Okay? And be 4x squared minus 6x minus 7. There's no problem with rewriting it underneath there so you have a better idea what's going on. Okay? When I add those, 3x squared plus 4x, remember, you're just adding the leading terms. You're not worried about the x's. The x's are along for the ride. And you should get 7x squared minus 8x minus 4. Now, with that setup, you can actually find the x-intercepts of that. We're not going to do it right now, not at least on adding or subtracting, but we will here brief in a moment. But this is basically what we want. You can add together basically quadratics, or essentially trinomials together, to get whole different combinations of lines. Okay? There are algorithms that do this. Okay?
All about the stats.
Don't worry, I'm just going to move it up to the add point. Everybody have everything up to the add point? Great.
Yes.
Okay. Now, directly underneath that, let's talk about subtract. Okay. So a weird way to word this would be you're going to add the opposite of the second polynomial. Okay. Same, change. Is another way to put that in an informal term. Okay. So an example of that being let's say I've got 5x squared minus 7x plus 3 minus 2x squared minus 4x minus 7. Again, bring it over here. Nothing wrong with stacking it. Okay. And from that, I get 3x squared minus 3x plus 10. Okay. Huh?
Can you stand this for a little bit longer?
The add part or the subtract part? Both?
Just subtract.
Okay. That's fine. All right. Like I said, we've already covered those in depth. I'm just focusing on getting down to where I want to get, which is on multiply. Now, with multiplication, okay, I'm going to do that in pencil. Oh, well. Whoops. All right. When we multiply by a monomial, right, which we've done in depth in terms with GCF, we've just done the opposite of it, okay?
What's with the dots?
Helps me figure out where and how far I need to go down.
Oh.
Okay. So, when we multiply by a monomial, I totally botched monomial. Like, I really misspelled that. M-O-N-O-M-A-I-L. Okay?
So it's like
Yes.
monomial.
Monomial. Okay? Right? We think mostly by distribution again, right? So we have 3x times 5x squared minus 7x plus 3. Okay. Whoops. We are going.
Do we close the parentheses after 3?
Yes. To distribute our leading monomial. Right? Again, we talked about this when we did GCF with polynomials. So again, this is more or less just to have a nice solid thing setup of this. So for example, we would have, let's just, I won't use that one, but I will use a different one here. So let's say I've got, actually I'll use that one. 3x, 5x squared, minus 7x plus 3, okay? And as always, we distribute. So we end up getting 15x cubed minus 21x squared plus 9x, okay? All right, I'm gonna stop the video there for part 1, and then part 2 will be talking about the other distribution.